So the second part of this video, as we saw, would be flat to fold, but instead of using Grasshopper components as we were using to generate those points, we can also draw everything in Rhino in a classic way, import that into Grasshopper and make them fold. And we'll be proceeding in a similar fashion. I will open first Rhino component degree for vertex I was using here. And here you can see like a degree for vertex, but for example, we have here some different stuff. We're going to start with valence 3 elements, and we are going to import this into Grasshopper and fold them exactly the same as we did. And to do that, you know that you can use a curve container, and we can select set multiple curves, and we select our mountains, for example. We do the same for valleys. And we do same for boundary. So in Crane, we will input from lines. It's a little bit messed up, but we know that this is this, and this is this. And the mesh we're going to generate, as you can see, is every element is triangular. So our valence is going to be 3. Actually, we're going to put a slider that has only 3 and 4, so it's almost like a Boolean. We proceed as we normally do. With a slider from 0.1 to 1 for fold speed and 1 to 10 for rigidity. Sometimes we need to play with this. We put a preview of the mesh that we are folding here, and if we reset, set solder on, activate rigid mode, we should be folding it. So this part is pretty straightforward. But what happened if all of a sudden, as for example, we were doing in class, we were trying to make a mutable unit cell, where we have, instead of like triangular elements, we have quads. Not a problem. So we're going to break this element, and we're going to make a quad element. And we need to clear all the values, empty, select multiple curves, we select our new shape, and we reset. And you can see that it's not happy with the valence 3 because there's an element that actually the maximum valence is going to be 4. So we should solve this issue as soon as we put valence 4 and reset. And now we are folding no problem. So that was the thing that was stopping us on the last recitation. Now we could easily make this beautiful. And in the previous tutorial, we were having some issues with the constraint of shape, right? Of target on surface. So for example, we are going to do now one thing. Well, this is the previous recitation. Let's jump to the current one. And imagine that I'm going to make a surface. It's going to be our target surface. And I'm going to simply extrude it. And I'm going to make here, and in order to see it better, I'm going to have the ghosted mode. And in geometry, I import one geometry. It's going to be this surface. I have it here. In the same fashion as previously, I want to see which are my vertex IDs. So I want to preview my vertex IDs. As I am going to say that vertex number 2 wait. I'm actually, let's unfold it to see. Vertex number 2, yeah, this one. And vertex number 4, I want them on the surface all the time. So as a constraint, I'm gonna put now on surface. Now we shouldn't have a problem. We will bring the C mesh here. We will put a panel, and we know it was like vertex number 4, vertex number 2. We set as multi-line data, vertex ID, constraints, constraints, CMesh. And now you can see that it's always satisfying in the numerical solution that those vertices will leave in the surface. Um, so this is the end of the 1.2 part, and I will upload another video with non-developable to developable or developable to non-developable to developable surfaces. This will be when instead of like starting from a flat surface, we will start with something that already we know it folds, or we know that it has a geometry that we can numerically simulate its folding, and then we calculate the folding using the crane solver.